All right, we've all gotten pretty used to AI that can chat, write code, and even make art. But what if it could do more than just, predict the next word? Today we're looking at what's next for AI, an evolution that's not just about talking, but about thinking.
So we know AI can talk. That's a given. But the real question, the one that's changing everything right now, is this. Can it think? Seriously. Because the answer to that question is what separates the AI we have today from the much, much more powerful AI that's right around the corner.
You've definitely heard of LLMs, right? Large language models. They are absolute masters at predicting the next word. But now there's a new kid on the block, the LRM, or large reasoning model. And the difference? Well, it's simple, but it's also incredibly profound. An LRM doesn't just talk, it actually thinks first.
So what does it even mean for an AI to think? Let's get into what really separates a simple reflex from genuine structured reasoning.
Okay, this is where it gets really interesting. An LLM, your standard model, kind of works on reflex. It just instantly spits out the next word or token in a sentence. But an LRM, it takes a pause. It actually sketches out a plan. It weighs different options, and it double-checks its own work in this sort of private sandbox. All of that happens before it even generates the first word of its answer.
And this means you've got to pick the right tool for the job. Look, if you just need a fun social media post, an LLM's quick reflex is totally fine. But if you're tackling something really complex, like debugging a gnarly bit of code or, tracing cash flow through 4 different shell companies, you need more than a reflex. You need reasoning. That internal chain of thought lets the LRM test out ideas and toss out the dead ends to find a solid, reasoned answer.
This all sounds pretty next level, I know. So the obvious next question is, how on earth do you build one of these thinking machines?
So, how do you build one?
Well, it turns out you don't actually have to start from scratch. The foundation of a good reasoning model is something we're all familiar with, a really powerful LLM. The goal here is to teach the model not just to answer, but to reason. It's like teaching a student to show their work in math class. During training, you give it a problem and you teach it to first create a plan, then execute that plan step by step, and only then, finally, arrive at a solution. It's learning a structured, logical way to think.
And this gets done using some pretty cool training methods. First, the model is fine-tuned on tons of logic puzzles and multi-step math problems. Why? Because that forces it to build an internal map of logic, not just word patterns. It also uses reinforcement learning, where it gets a little reward for taking a good step in its reasoning process. And then there's this technique called distillation, where a bigger, smarter teacher model basically shows a smaller student model how to solve problems, passing down its wisdom.
But of course, this kind of advanced brain power doesn't come for free. There's a very real cost to this deeper level of thought.
When you give the model a prompt, you have to decide how much thinking time or compute allowance it gets. Think of it like a budget. A simple task like writing a quick caption gets a tiny budget. It gives you a quick single-pass answer. But a really complex task like debugging code gets a much larger budget so it can explore different paths and check its work.
And a bigger compute allowance translates directly to this: more GPU dollars. Every extra thought, every self-check, every search for a better solution adds to the processing time and, you guessed it, the cost. Deeper reasoning is literally bought with more time and more money.
So this sets up a classic trade-off, right? When should you go for the smarter reasoning model versus the faster, more reflexive one?
So here's how it breaks down. The power of an LLM is obvious. It's fantastic at handling complex logic, which gives you way more accurate answers. And a huge plus? Less prompt engineering. You don't have to keep telling it, let's think step by step, because it just does that automatically. But the price for all that power? Well, higher compute costs, slower replies, and yeah, a bigger bill from your cloud provider. It really forces you to ask, is the extra thinking actually worth the cost for this specific task?
So, what does this all mean for the future of AI? Well, it signals a pretty major shift in what we're starting to value in these models. This quote really nails it. We're moving away from just wanting models that can spit out words as fast as possible. Instead, the most advanced, the most powerful AIs are now the ones that actually take their time to think. In fact, if you look at the AI leaderboards today, the models scoring the highest are almost always these reasoning models.
And that leaves us with a final, pretty fascinating question. We've already seen what AI can do when it masters language. But what happens when it masters reason?
What kinds of problems will you solve when the AI you're using doesn't just talk, but truly deeply thinks?